Hi everyone, I'm Muhammad Haizan Putra from DAD Class C. We'll present about gas metal arc welding and gas tungsten arc welding, which is Gmaw and Gtaw. I will explain about the method of welding and the welding machine, shielding gas, and electrode used in both. So, let's start from Gmaw. For your information, Gmaw, also known as MIG welding. MIG welding is a semi-automatic arc welding process that uses a continuously fed wire, electrode, and shielding gas to join metal and arc electric form between the consumable wire and the base metal, melting both and fusing them together, while the shielding gas protect the molten weld pool from atmosphere contamination. So, how it works? First, method of welding, which is an arc is created between the continuously fed consumable wire, electrode, and the workpiece. The arc and weld pool are shielded from the atmosphere by externally supplied gas. Second, welding machine. Welding machine require a constant voltage power resources, which is DC or AC, a wire feeder, a welding gun, and shielding gas supply. So, how about Gtaw? Gtaw have a bit different. So, let me explain. Gtaw or gas tungsten arc welding, also known as a TIG welding. This process uses a non-consumable tungsten electrode to create a weld. The weld area is protected from atmospheric contamination by inert shielding gas like argon and helium. This process is highly versatile and it is often used for welding thin section of various metal such as stainless steel, aluminium, as it allows for precise control. So, how about the method of welding? Method of welding. The arc is created between the non-consumable tungsten electrode and the workpiece. A filler metal is added manually or automatically. The arc and the weld pool are shielded by the inert gas. The welding machine requires a constant current power resources, the same like Gmaw, which is DC and AC, welding torch, and shielding gas supply. Shielding gas supplies mostly use argon and helium to protect the weld area from atmosphere contamination. The electrode is non-consumable because only serve to create the arc, but it does not melt and become parts of welding. But sometimes, welder also use filler rod during the Gtaw process, and it's called fusion rod.
Okay, hello guys. My name is Vignesh Varyan from class DAD1C. Right now, I'm gonna discuss about the type of current and polarity used in both Gmaw and Gtaw and the effects of polarity on the welding process. First, Gmaw. Current and polarity. It typically uses direct current electrode positive DCEP, also known as reverse polarity. The effects of the polarity DCEP is that it provides a stable arc, good penetration, and a smooth weld bead. The majority of the heat is concentrated off the workpiece, which is ideal for welding thicker materials. As for Gtaw, the current and polarity use direct current electronegative, that is called DCEN, also known as straight polarity or alternating current, AC. The effects of polarity, basically DCEN, they have two. One is DCEN and one is AC. DCEN concentrates heat on the workpiece, resulting in deep, narrow welds. It is used for welding steel, stainless steel, and titanium. Well, for AC, it provides a cleaning actions that breaks up the oxide layer on the surface of the metal, which is crucial for welding aluminium and magnesium. That's all.
Okay, hello, my name is Ryan Zakaria. So I'm gonna talk about disadvantage and advantage of Gtaw and Gmaw. So today I'm gonna talk about it. So compare the advantage and disadvantage of Gtaw and Gmaw is first Gmaw, the advantage is high deposition rate, faster welding speeds, and is easily automated, and it is cost effective process for welding a wide range of material. And for its advantage of Gmaw is less portable than other methods like shielded method arc welding, and the equipment is more complex. It also susceptible to wind, which can blow away the shielding gas. So for the advantage of Gtaw is produce high quality, precise welds with no spatter. It is ideal for welding thin materials and for application where aesthetic are the important. And for the disadvantage is slower than other welding process. Requires a high level skill to perform and is more expensive, and it also has a low deposition rate.
My name is Muhammad Arif Hakimi. Right now, I going to identify common welding defect and the prevention method. Firstly is porosity. Description is a small void or holes in the weld metal caused by trap gas. Uh, Fermentation is ensure the workpiece is clean, use the correct shield gas flow, and use dry electrodes. Second is undercut. This description is a groove metal into the base metal next to the toe of the weld, which is not filled by the weld metal. The fermentation is use a proper travel speed, the correct current, and a suitable electrode angle. And third is fusion, incomplete fusion. The description is a lack of fusion between the weld metal and the base metal of or between adjacent weld bits. Fermentation is ensure the welding current is sufficient, the travel speed is correct, and the joint is properly prepared. And the lastly is a cracks. Description is a fracture in the weld metal or heat affected zone. And the fermentation is preheating and workpiece using the correct filler metal and controlling the cooling rate. That's all for me.
Hello, my name is Muhammad Fidos and I'm going to describe types of distortion in welding and how to minimize them. First is welding distortion refer to unwanted change in shape or dimension of metal parts caused by heat. It affects the fit, strength, and overall appearance of welded structure. Next is there are many types of welding distortion, such as longitudinal shrinkage, transverse shrinkage, angular distortion, reverse buckling distortion, rotational distortion, and bending. Lastly, the technique to minimize distortion is do a proper welding sequence to help balance heat input for better result. Next, use of fixture point clamps to secure parts in place to prevent movement. Lastly, preheating metals to reduce thermal gradients for smoothing welding.